In macroeconomics, employment is an important variable that has economic as well as political repercussions. So we are interested in finding out some derivatives of employment. By derivatives, we don't mean any mathematical tool. We mean that something which is calculated by using the employment variable. And in this case, we are interested in calculating the per capita employment. This is the derivative that we are talking about. So per capita employment would tell us that out of a certain segment of population or total population, what will be the employment. So for that we can use some mathematical tools, that is the rate of growth tool, in which we will be using employment which will be using the natural log and the derivative. So let us do this thing, and for that we want to calculate the per capita employment, and the growth rate is there, which is represented with E, which is represented with A, and E is the overall uh, employment opportunities that are there, and growth rate of population is also given, which is B, and P is the overall population which is there. Now the employment per capita would be an interesting thing to find out. Primarily it will be the ratio, as we already developed this thing, that the employment opportunities and the population, when we take their ratio, we get the employment per capita. So this is the definitional equation of it, and we can take the natural log on both sides. This will give us this form, which is simply by applying the laws of logarithm, and then we can calculate the derivative. And you know why we are doing this, that is natural log as well as the derivative, because we want to find out the rate of growth, and this is what gives us the rate of growth. So when we took the derivative, definitely it was applied on both sides, and we applied it by using the difference rule of differentiation. So it is also applied here. Now you know that when we take the derivative of a natural logarithmic function, it appears in the denominator and its derivative appears in the numerator. So this applies to this form as well and this term as well. Here and here we can see that they are getting expanded by using the derivative of a natural logarithmic function situation. Since we know that derivative of a natural logarithmic function is actually the rate of growth of that certain variable, so we can write it like this, that is RC, and then RE and RP. So in this way the rate of growth of per capita employment is calculated by calculating the difference of the rate of employment opportunities and rate of growth of population. We know that the rate of growth of employment opportunities was represented by A, and the rate of growth of population was represented by B. So we can substitute these values to make it more understandable. We are given, you know, these equivalents that we just talked about, and also we are given the numerical values of these two variables, that is these growth rates. One is 4%, other is 2.5%. So we put the values here, and the values are 4% minus 2.5%, and we get 1.5. So this is the growth rate of per capita employment, which was actually equal to the difference of the growth rate of employment and the growth rate of population respectively. So using this tool and the formula of rate of growth, we can find out the the growth rate of any variable, in which case, in this case it was the per capita employment, and we can extend this to any other economic situation wherever the rate of growth is to be found. Thank you.